Hello everyone, today we will discuss vector form of equation of if u is the initial velocity of a body and a is its constant acceleration, and after t second let us say that its final velocity is v and displacement is s, and the condition is that the motion is taking place in a straight line motion, then the equation of motions are written as v equal to u plus at. Here v is final velocity, u is initial velocity, a is acceleration which is constant, and t is time. The second equation is s is equal to ut plus half at square. Here s is displacement, and the third equation is v square equal to u square plus 2as. It is important to note that when the equation of motion is taking place in a straight line, then we can add the vector quantities like the scalar quantities. Here, the initial velocity and the acceleration are in same direction. That is why we can add these quantities like the scalar quantities. But if initial velocity and acceleration of a body are not in same direction or are in different direction, then we cannot add these quantities like the scalar quantities. Then our equation of motion will be written in vector form, and in vector form we will write the equation of motions as v is equal to vector u plus vector a into t, and vector s is equal to vector u p plus half vector a t square, and the third equation of motion will be v dot v is equal to u dot u plus 2a dot s. The first equation of motion in vector form we can represent it as, here u is the initial velocity and it is represented by the vector u, and at is the other vector which is making an angle of theta in anti-clockwise direction from vector u. Then the resultant vector v will be equal to vector u plus vector a t. Here this is your vector u and this is vector at. This is tail of the vector u, this is head of the vector u, and this is the tail of the vector at, and this is head of the vector at. Then our resultant vector v will be equal to u plus at. You can see here that in case of the addition of the vectors, you see that the final vector v, it is matched with tail of the vector u and head of the vector at. The second equation of motion in vector form will be written as vector s is equal to ut plus half at square. Here first we will draw the vector ut and then vector half at square. First we will draw vector ut and then vector half at square. This is the tail of the vector ut, this is head of the vector ut, and this is tail of the vector half at square, and this is head of the vector half at square. So when we find the resultant vector s, then we see that the tail is matched to tail and head is matched to head. So your vector s is equal to ut plus half at square. And the third equation of motion will be written as v dot v, because you know that v dot v is equal to v square equal to u dot u, it is equal to u square plus 2a dot s. You also know that I dot I A dot j, k dot k is equal to 1, and I dot j, k dot k, k dot I is equal to 0. Now we will discuss the projectile motion. When a body travels with such an acceleration that it is in different direction from the initial velocity of the body, and also the magnitude and direction of velocity changes with time, then path of the body will be curve like, then the motion is projectile type. We will discuss later the projectile path, and for the projectile path we will find equation of motion, height of the projectile, range of the projectile, and time period of the projectile. Here it is very important to note that the acceleration of the body and initial velocity are in different direction, and the motion of the body will be projectile type. Thank you.